Hello everyone. So in this lecture we are going to see that how to find the minimum spanning tree of graph by using the Krushkal and Prim's method. Already we have discussed the two algorithms in details and we understood their approach. Now sometimes we have to quickly apply these algorithms into the graph to get our MST. So we'll take some example and find out quickly our MST, the minimum spanning tree of the graph, by using these two methods. So let's discuss some examples. So the first method we are going to talk about the Prim's method. We assume that one graph is given to us along with some information, and we need to quickly find out some other information using this approach. So let us assume the graph given to us will look like, let me draw the graph here. These are the weights of the edges. Okay, so the graph is given to us. Here we have 6 vertices in this graph, and we are interested to find out the minimum spanning tree using the Prim's method. Along with the graph, we are also provided the table which uh, which gives the key value for these vertex. So here you can see the first row is for the vertex. So here this u is the vertex of this given graph and the key value. Now key value, the significance of the key value is it is a value that tell us that what is the cost incurred to reach to the predecessor node. So key value is basically referring the cost of moving from the predecessor to any node, and pi u is referring to the predecessor node. Now we already discussed that in the Prim's method we are always caring for the predecessor node because that node is actually guiding us that where to move. For example, if we have to go to 3, then to go to 3 we have 1, 2, 2, 5, 6. We have many possibilities are there. So this predecessor node will tell us that to reach to 3 which node we have to follow. Now this is given to us and we are required to find the predecessor node for this given graph. Now this is already given that the minimum spanning tree can be find out using using these key values. This is already given to us. In that case, the predecessor for this graph will be, we can just go to the vertex 2 and you can see that what is the edge whose weight is 5. So we can see that this is the edge whose weight is 5. So we can say that the predecessor for 2 is 3. Similarly, we can go to the vertex 3 and we look for any edge whose weight is 1. So this is the edge. That means to go to vertex 3 we have to go from 1. So 1 will be the predecessor of vertex 3. Similarly for 4, now we can do quickly. So from 4 this is 6. From 5 the cost is 3, that means 2. And for 6 the cost is 4, that is 3. So that means to go to 3, from 3 we can go to 2, from 3 we can go to 2, and from 1 we can go to 3. And also you can see that our tree must be connected all the time because we already discussed in the Prim's method. And from 6 we can go to 4. So because since the tree must be connected, so we will go again from 3 we can go to 6. So we go to 6 here, and from 6 we can go to 4. And so we have taken this, we have taken this, we have taken this, we have taken this, and from 2 we can go to 5. So this is our spanning tree, you can say minimum spanning tree of the given graph. And in order to find out the cost of the spanning tree, we simply add all the values of the key for the given vertex. So here these are the key values that exist for any vertex. So you simply add all these and that will give the cost. So this will be 5 plus 1 6 plus 2 8 plus 3 11 plus 4 15. So the cost of this is 15. Now in the same way, in the vice versa, here we have provided the key value and we are asked to find out the predecessor of any of the given nodes. Now here the pi-u is given to you, that is the predecessor node is given to you or the previous node is given to you, and we are asked to find the key value. So one thing to keep in mind, this is blank because we are assuming that 1 is the root node. When we work with the Prim's method, we need to provide one vertex to start with. So here we are assuming that we are starting with vertex 1. So here if the 3 is predecessor for 2, then the cost is 5. If the predecessor for 3 is 1, then the cost is 1. If the predecessor for 4 is 6, then the cost is 2. If the predecessor for 5 is 2, then the cost is 3. If the predecessor for 6 is 3, then the cost is 4. So the question can be asked in any way, and again if you want to find out the cost of the minimum spanning tree, you can simply add all this and you can find this will be the same 50. So quickly we can do it provided what kind of information is given to us in the question. So this is one way of asking or applying the Prim's method for the given graph. Okay, then we'll see one more example and we'll see that what information we can get from the Krushkal method. Okay, this is one graph given to us and we already discussed the Krushkal method. In the Krushkal method, we sort the edges in the ascending order, and then we for all the edges we are applying some operation, and the operation we are actually doing the find set and the union operation. So if you want to find out the minimum spanning tree by going step by step, it may take some time, but sometimes we have to quickly identify the minimum spanning tree. So how we can do it quickly? So keeping the logic of Kruskal method, it's a greedy approach, and we have to work with the smallest edges. Means we have to work with the edges which have a minimum weight. So we have to look to all the weights which is assigned here. So here this is the minimum. So that means we are going to select this edge, and when you select this edge, these two vertices are selected. Now the purpose of the minimum spanning tree is to make a tree that can include all the vertex of the given graph. So we have, when we select this edge, these two vertex are included, so this is now no more in the graph, so we have just removed there. Then the next is 4. So this is 4 edge, but before picking this edge, you have to check that the two vertex are already included or not. So here you can see that when we take this edge 4, here one of the vertex is included but other is not included. That means we can still consider this in our solution. Now this is out. Then the next is 6. Now before moving to 6, you need to check that the vertex that actually occurs at the end of this edge will be included or not. So this is already included. That means we are not going to pick this edge in our solution. Then we go to the next. So the next value will be the 7. So here you can see that still we have the possibility to include this edge. Okay. Then next is 8. So we will again include this. Now at this point of time, you can find that all the vertex have been crossed. Crossed means it's already included in our solution. Now there is no need to check for all the edges, and we have already find our solution. So our minimum spanning tree cost is actually 3 plus 4. We have used this edge, and 4 plus 7 plus 8. That will give you 7 plus 7 14, 14 plus 8 22. So the cost of the minimum spanning tree for this given graph is 22. Now let us look on these questions. Does edge BG will be included in the solution? So if you look to this approach, you will find that this is BG which is not included, because we are working in the greedy approach, and while working in this we have already included these vertex before we move to BG. So this will not be included. What is the cost of minimum spanning tree? The cost is 22. How many vertices in the MST of given graph? So one thing to keep in mind, we have to include all the vertex of the graph in the MST. So this consists of 5 vertices. So we have to include 5 vertices in our MST. How many edges? So always when you make an MST, whenever you make a minimum spanning tree or the given graph, it will always be one less than the given number of vertices. So here we will take 4. So in general, if you have n vertices in the graph, then your MST will contain n minus 1 edges. Okay, so this is all for this lecture, and this is just to understand some key points of Krushkal and Prim's method while finding the minimum spanning tree of given graph. Okay, so we will discuss more in the next lecture. Thank you very much. That's all for this.